ready to start a new unit. This unit is all about graphing, and graphing comes in pretty handy in pretty much all your science classes. In physics and chemistry and biology, different graphs are used for different things. So we're going to do kind of a general graphing review, especially about linear functions, and then we're also going to look at some specific applications for physics. So this is Lesson 0, Graphing Review. Recall that in math, we learned equations of the form y equals mx plus b, are also called slope-intercept form. These are linear equations, straight lines. And we define slope as m equals y2 minus y1 over x2 minus x1. If we have 2 points, y1, x1, and x2, y2, or we also define it as rise over run if we've got a graph that we're working with. And rise over run ends up being pretty helpful most of the time. It's only for given points directly that we usually use this formula. So, a few examples. It says graph the following on the grid to the left. So let's see how this works. So we've got y equals 2/3 x minus 4. So we always start by graphing the y-intercept. Remember that the b, this is your y-intercept. And that's the first point we're going to put on our graph, if at all possible. So in this case, this minus 4 is my y-intercept. This is where I cross the y-axis. So minus 4, here's my y-axis. I'm going to cross the y-axis at minus 4. So I'm going to put that point right on my graph. There's my y-intercept. And from there, I'm going to count, here's my slope is 2/3. I'm going to count my rise over run. And a positive slope is going to go up to the right. A negative slope, not slop, slope, is going to go down to the right. So this is a positive slope, which I should expect to be going upwards as I go to the right. So from here, again, this is going to be my rise is 2, so 1, 2. Run is 1, 2, 3, and that's where my next point is going to be. Do it again, rise 1, 2, run 1, 2, 3, rise over run, there's another point. Once you got 3 points on the graph, if you've got a ruler, you should take out your ruler and connect them. Connect them all up all the way to go all the way off the graph, put an arrow on that end, and then connect them up all the way off the graph, put an arrow on both ends to show that it keeps going forever and ever and ever in both directions. So again, start with your y-intercept, then take a look at your slope as rise over run. Next example, again, start with my y-intercept is positive 5. So I'm going to go to my y-axis and count up 5. 1, 2, 3, 4, 5. There's my first point. And then my slope is negative 2. Now, it's not a fraction in this case, but I can turn any whole number into a fraction by making it over 1. So I haven't changed the number. It's still negative 2 because divided by 1 doesn't change anything. And this is, again, my rise over run. But this time, negative slope, I should expect to be going down as I go to the right. So I'm going to go from my 5, I'm going to go down to over 1, down to right 1, down to right 1. As long as you have 3 points, that should be enough to be able to connect them up, get a straight line. Make sure it goes all the way to the bottom of your graph, put an arrow, and then up in the other direction, all the way off your graph, put an arrow. So that would be my second. So this is the equation y equals negative 2x plus 5. I should really be labeling these. And this is my equation y equals 2/3 x minus 4. Let's try another one. This time I have the equation y equals negative 8. So first you got to ask yourself, is this my slope or is this my y-intercept? Is it both? What is it doing? Well, your slope always has to be with your x. So if there's no x with it, this must be my y-intercept, negative 8, because there's no slope, there's no x with it. So I'm going to count down, here's negative 5, 6, 7. I've got my y-intercept of negative 8. And the fact that there's no x term appearing actually tells me that my slope is 0, because 0 times x would give me 0, it just disappears. 0 minus 8 is just minus 8. So my slope is 0, and again, I can turn this into fraction. 0 over 1 means my rise is 0 over run 1. So rise of 0, run 1 is going to end me here. Rise of 0, run 1, and I end up with a horizontal line at y equals negative 8. So this is important for you to remember. We're going to get some horizontal lines going on later on. But for y equals negative 8, horizontal line has a slope of 0. And it's going to go through my y-intercept of negative 8, still the y-intercept. Last one. Let's do that one in red. I've got y equals negative 1/2 x. Now in this case, we said this one was the y-intercept because there was no x with it. This must be the slope because there is an x with it. So in that case, I know what my slope is, negative 1/2, but I don't know what my y-intercept is. So again, in the case of when my x term disappeared, I had a 0. That's going to be true in this case as well. If I add 0, something plus 0, the 0 just disappears. Something plus 0 is just itself. So my y-intercept is then going to be 0. So I'm going to have this point here, y-intercept of 0, and then my rise over run is negative 1 over 2. So again, negative slope should go down to the right. So I'm going to go down 1 over 2. Down 1 over 2. Once you've got 3 points, you can connect them up. Take it all the way off your graph. Put an arrow on that end. Same thing in the other direction. All the way off your graph. Are we on the right second? There we are. Put an arrow on that end. So this is y equals negative 1/2 x. So if you have a slope and no y-intercept, your y-intercept is 0. If you have a y-intercept and no slope, you're looking at a horizontal line. So that was a review of graphing from grade 8, grade 9. Not even sure when you learned to graph a straight line for the first time. We're going to do some practice of that before we actually start applying physics in here.